Okay, so I'm going to review the last lecture. We talked about different subsets, correct, of R, real numbers. And we know real number is a set of all the numbers, possibly we have in math, correct? And we talked about different subsets. The first one was natural number, correct? Natural number starts from 1. We show that with n. 1, 2, all the number up to
infinity.
Infinity.
You're so smart.
And then we have whole numbers.
That's,
W. It starts from 0.
That's all real numbers, including infinity.
Not all real numbers.
I'm just kidding.
All natural numbers, including 0, correct?
Yes.
And then we have integers, Z. All the negative and positive of whole numbers, correct?
Yep.
And then we have rational numbers, which said there is this fraction we are using, A over B. A is integer, B is integer, correct? But B cannot be 0. Why? Because this fraction becomes
Rational.
no. It becomes undefined.
Undefined.
Any number divided by 0 is undefined. So, this is rational number. We talked about terminating decimal. We said has finite numbers of digits. Like this one, 5.34, correct? And then we talked about repeating decimal. When we have some numbers repeating over and over and it has the same pattern, correct? And we can put a line above those repeating numbers, like 13 in this example. So we said rational number includes both terminating decimal and repeating decimal and integers, because we can have 2 divided by -2 equal -1, and -1 is rational number, and then we know -1 is integer, correct? So that's fine. Both of these decimal and also Z, which is integer. So this is rational number. And then we have irrational numbers. Irrational numbers are non-terminating decimal. Means the number after decimal will be like many numbers and we cannot find the end point, correct? So we don't have any end point for decimal. We cannot understand what is the last digit after decimal. So that's a non-terminating decimal, correct? And pi, a square root of 2, all of these, if you calculate that on your calculator, you will see lots of numbers after decimal, means non-terminating. So these were all the subsets of real numbers. And then we talked about some properties of these numbers. What happens if we add them, subtract them, multiply to 0, multiply to 1, and different properties, reciprocal of these numbers, or anything like that. And then these two, never forget. Any number divided by 0 is undefined. 0 divided by any number is 0. Never forget this. Okay, so then percentage is so simple. Out of 100 is percent. So any number out of overall multiplies to 100 will give us a percentage of that specific group out of overall number. So now we want to talk about absolute value, because last time we talked about this and we said this is a real number line, and we have the midpoint is origin 0. We have all the positive numbers to the right side, all the negative numbers on the left side, and this includes all different numbers, because between -1 and -2 we have lots of decimal, correct? Either terminating decimal or non-terminating decimal or repeating decimal, anything, correct? Rational, irrational, any kind of numbers. So this is a real number line. And what else? I'm going to use this kind of to explain absolute value. Absolute value of any number is positive of that number. First, I will bring example, and then I will explain how it exactly works. So, absolute value of 3. As you see, we have two lines on front and behind the 3. So, absolute value of 3 is 3. Absolute value of -3 is still 3. It means whatever numbers we have inside the absolute value, positive, negative, becomes positive. So how it works? The really good definition of absolute value is this. Distance from 0 to that specific number. Now, on real number line, if I want to see what is the absolute value of -3, distance from 0 to that specific number, which is -3, correct? So where is -3? Here. So I will count 1 distance, 2, 3. And this 3 that I said is the value of absolute value of -3. So distance from 0 to that number. Now let's say absolute value of 3, correct? 3 is this side. So I'm counting from 0. 1, 2, 3. So absolute value of 3 is 3, correct? Absolute value of -5. What is that?
5.
Absolute value of -5 is
5.
5, correct? So now I want to count. I said distance from 0 to that specific number, -5. 1, 2, 3, 4, 5. So absolute value of -5 is 5, correct? Do you get that? So this is the most proper definition of absolute value. But now you can easily say whatever we have in absolute value, positive, negative, becomes positive, correct? But you know what is the real definition, how it exactly works now. Distance from 0 to that specific number is absolute value of that number. Okay, so this notation is more advanced way of explaining absolute value. I will just explain it to you. You don't have to memorize it or remember it. Just I want you to have a knowledge of this. So we have absolute value of any number. X can be -3, 3, +3, whatever, correct? So that number, let's say absolute value of -3. So we know -3 is a negative number, correct? So the condition is -3 is negative number. So we should choose the second condition. So there is a condition here. It says x is less than 0. We know x less than 0 is negative, correct? X greater than equal to 0 is positive number. So when I have absolute value of -3, means I should choose the second condition, correct? Is that clear? So I'm going to use the second condition. Second condition says, instead of x, put that number. What was my number? -3, correct? So negative of -3 is +3. So this is the way this formula works. So if I have absolute value of 5, which of this formula I should choose? Absolute value of 5. The top one, because 5 is positive, correct? So I will write down just 5 because we don't have any other sign in front of that, correct? So absolute value of 5, just this formula, instead of x put 5, that's it. And that will be absolute value of 5 equal 5, correct? Do you have any question? Anything? So, the example here was -5 also. So I don't know, for some reason I like 3 and 5 probably. These are only my examples. Okay, so adding, subtracting numbers. This should be easy for you. But let's tell you. So if I want to just show that on real number line how everything works. Maybe some of you forgot how you add or subtract. I mean, kind of real definition of adding, subtracting. Okay, if I want to, let's use my favorite numbers, 5 and 3. Okay, so I start with 5. I start with 5 on real number line. Do you see that? So 5 is here, correct? And then how many units I should go forward? 3 units. Why I'm going forward? Because it's positive, correct? I'm going to the positive direction, correct? So add that, 5, 6, 7, 8. So that's a real definition of adding and subtract. Let's say I have 5 minus 3. What happens? I start with 5, and then the direction says go backward, because that side is all negative numbers, correct? How many units? 3 units. So let's go back. 1, 2, 3. Okay? So this will be the answer. 5 minus 3 is 2. And then negative, positive. Some of you definitely should know how this kind of things work. Like, say, I have 2 minus 5. So, you know, whatever is the result should have the sign of bigger number. Sign of bigger number is 5, correct? It's negative. So the answer should be negative something.
Negative
3. So now let's look at this. I'm going to start from 2 because the first number is 2, as you see, correct? So starting from 2, going backward, correct? Because we have a negative sign. It says go to the negative direction. So how many units? 5 units, correct? 1, 2, 3, 4, 5. This is the answer. So this is the way addition or subtract works exactly on real number line. But most of you should memorize that. The bigger number, whatever sign is there, you will use that sign as a result, correct? And then you will take 2 out of 5, remains 3, okay? So, do you have any question? So if you have any number divided by another number, like say negative a divided by b, because a and b has different sign, the result will have negative sign. So if they have both same sign, the result will be positive. These are something you should already know. You should, if you don't remember, you should review this. Negative a number multiply positive number, result will be negative, correct? Negative multiply negative, result is positive. So, properties of, performing mixed operation. So if you have a long set of numbers all together, plus, minus, multiplication, division, all of this, always start with parentheses. Look to find a parenthesis and solve whatever you have inside the parenthesis. This is the first step. And then start from left to right. And from left to right, do all multiplication and division first. And then at the end, addition or subtraction. Okay? So power. A power B. A power B. The example would be 2 power 3. Do you know what is 2 power 3?
Is this section?
Huh?
Is this section not the 3?
Oh, this one, yes.
Okay.
This section 3. I
Just making sure.
So, 2 power 3. It means multiply 2 to itself how many times? 3 times. So the result will be 2 multiply 2 multiply 2, which is 8. Correct?
Mm-hmm.
So 3 is power. 2 is the base. So this is base, this is power. So now I will show you something. Let's say I wanted to calculate 2 power negative 3. It seems difficult.
You can't do negative exponent.
We can. Let's say I wanted to ask you what is 2 power 0.
You can't
It
do
seems
that.
difficult. We can.
Or you can. Oh, it's like x equals 0 or something. It's something like that.
That one you are talking about is expression. Chapter 2, we will talk about that. We cannot have a negative exponent for those. But these are just values. These are not like variable. These are not unknown. These are known, correct? You know this is 2, this is a number, this is 0, 0 is number, correct? So let's say you don't have any idea how to solve this. I will show you a pattern. That pattern easily give you the answer for this kind of power. So I'm going to write down vertically. I will start with 2 power 3 that I already know and calculated. These are something you should already know in your like timetable or this kind of things, you know, 2 multiply 2 multiply 2. So you already know it's 8, correct? So now, what is 2 power 2?
6.
4.
4. I'm sorry.
2 power 2 is 4, correct? 2 power 1. So let's talk about this. I said 3 times multiply 2 to itself, correct? 2 times multiply 2 to itself means 2 multiply 2. And this one, if power is 1, means just multiply 2 to itself 1 time. Means just keep the 2 the way it is. You're not multiplying anymore to anything, correct? So 2 repeats just once. 2 repeats 2 times. 2 repeats 3 times. Okay, so these are something you should already know. But now look at this. From 8 to 4. If you divide 8 by 2, you will reach 4, correct? If you divide 4 by 2, you will reach 2, correct? So if you forget what was 2 power 1, you can go backward to see what is going on, what is happening. Divide every step by 2, and then you will reach this step. So now, let me write it down more. Actually, this one goes here, this one goes here. Or let me write it down in this way. From here to here, you can divide 8 by 2. From here, 4 by 2. This is much easier to understand. Okay, so now think, and then raise your hand if you know the answer. What is 2 power 0?
What is it? 0. It's not 0.
Raise your hand.
0. Undefined.
No. 1.
Oh yeah.
You also wanted to say 1? How? We divide this by 2, correct? 2 by 2 is 1. That's it. We are going backward, correct? Divide everything by 2. So now, you know what is my next question, don't you? 2 power?
You can't do that.
We can do that. Who knows the answer?
0.
No. No.
I'm gonna Google this.
Come on. There was a pattern. I showed you.
2.
1 divided by 2. Exactly. Because here is 1. Divide that by 2. The answer is 1 over 2. Correct?
1 over. Oh, is it the reciprocal when you do negative?
Doesn't matter what power you have. Follow this pattern. You will reach that. The power is decreasing. 3, 2, 1, 0, and all of them are like following a pattern, correct? So I am over and over going to the next step. What is 2 power negative 2? Come on.
2 over 1. 1 over 2. I don't know.
1 over 4.
Wait, why is it 1 over 4?
Because 1 divided by 2 divided by 2 is 1 over 4. Is that correct? half divided by 2 is 1 over 4.
So if you were to do 2 to the negative
3,
it would be 1 over 6.
1 over
6.
8.
1 over. What? Why
1 over 4 divided by 2 is 1 over 8.
1 over 4 divided by 1 over 2 is 1 over 2.
No. You should work on your timetable again. Because it will be 1 over 2 divided by 2. We have 1 over 4 here. And then if you want to continue, just divide the result by 2. So, did you understand this matter?
I think so.
Now I want to talk about another base, like 3. See if you understood everything. So, 3 power 2 is equal to
6, no, 9.
9. 3, just look properly. Then if you know the answer and you know you're right, say 3 power 1 is
3.
why? What you did?
You divided it by 3 and 3 divided by 3 is 1.
9 divided by 3, correct? Correct? So here we had base equal to 2. That's why we found everything divides by 2, correct? Step by step. But here the base is 3. Everything is divided by 3. 3 power 0 is
1.
1. Correct? Do you see that? 3 divided by 3. So, and 3 power 1 is, negative 1 is 1 over
1 over 3.
3. Correct. 3 power negative 2 is 1 over
1 over 9. Because 3 times 3 is 9.
in denominator. Do you have any question? So, in worst case scenario, you forgot what is 3 power 0, what is 3 power negative 1. You can follow this pattern and it will kind of remind you of everything, the relation. Okay, so if we have, I'm still talking about base and power. Do you want to write this down? Did you write down? So I'm going to clean this part of the board. Okay, so now I'm going to give you some rules to multiply two powers. So this is 2 power 3, correct? Multiplies to 3 power 1.
24.
No,
you have to add the exponents.
Sorry, I should have the same base.
16.
Because you're calculating this one multiplied by this
add.
one. So instead of doing that, there's an easier way, kind of easier way, in a big, huge exponent. In this way, this is so easy to multiply, calculate this one, and then multiply them, correct? But there is a rule for that. The rule says if the base are the same, so as you see, base are both 2, correct? Keep base and then add the exponent. So what happens? 2 power?
The power becomes 1. It becomes 4, so it's
2 power 4 is
power 4.
16, because 2 multiply 2 multiply 2 multiply 2.
Oh, that's how
Okay? So whenever you have the same base, write down a base, add the power. Okay? So now, the next rule says, when you have division,
you subtract the exponents.
if the base are the same,
You subtract them, but if
Yes.
they're not, I forgot what you did for
3 minus 1. How? The first exponent minus the second exponent. Or you can say the exponent of numerator minus the exponent of denominator. It's always the way If you go other way, you will have a wrong result. Because there's a possibility of having negative and positive exponents. Like if I had -1 here, what would I do? Minus -1, correct? And then you should figure out minus, multiply minus is positive, correct? Then it would be 3 plus 1. So always be careful.
Wait, that's only if it's a negative, right?
Yes.
Which in this case, it is, or it's not?
No, I had just example.
Oh.
Now, I want to keep that first example and say, so 3 minus 1. Now you know, this is the rule. Exponent of numerator minus exponent of denominator. So if you have negative number, positive number, just be careful. This one minus this one. Correct? And put whatever exponent you have in a parenthesis, so you know if it is negative, if it is positive. The negative outside parenthesis will have effect. Yes? So I'm going through this briefly. Why? Because again, in other chapters, we are going to talk about this more and more and more. This is just, for you, how these properties work, just, kind of understanding how these things work. And then we have one more thing which is interesting. When sometimes you will see base, power, one number, and then all over will power to another number.
You have to multiply them.
We will multiply the exponents.
Yeah.
We will write down base 5, then 2 multiplies to 3, so 5 power 6, correct? So this is also another row.
Could you do a negative subtraction one again?
Yeah.
Division.
Did you understand this? So this is always a rule. If you have 2 exponents, you should multiply the exponent. So now she wants me to give another example of division. 3 power -5 divide by 3 power -2. So as you see, both of exponents are negative number, correct? So the first step to apply the rule is to recognize if the base are the same. The base are the same here, correct? Keep a base. And then start with the power here.
Power
Numerator. -5 minus
-2.
negative.
And keep change.
Yes. 5 plus 2 is
-3.
3 power -3.
So it would be 3 to the power of -3.
And now later, if I ask you what is 3 power -3, you will continue this one. Correct? Divide this one by 3. So you will have 1 over 27.
Wait, why 27?
Because 1 over A divided by B is 1 over AB.
Okay.
1 over 9 divided by 3 is 1 over 9 multiply 3.
Oh.
This is the way it works. So let me, now because I said that, let me give you a kind of trick in case you see such a fraction, 2 fractions divided by each other. One over 9 divided by 3.
That would be 1 over 27.
So now I want to go step by step and show why that happened
So
exactly.
that's 1 over 9 times 3. And then
3 here is just one number, correct? It can be 3 over 1. Is that correct?
Yes.
Any number.
Or
But
any
2 means 2 over 1 because any number divided 1 is itself. Is that correct?
Yes.
Do you get that?
Yes.
So instead of 3, put 3 over 1. And then this is so easy. If you have more complicated numbers, this trick works really good. So far multiply far goes to the numerator. Close multiply to close because these two are close together, correct? These two are far from each other. Far to far goes there. Close to close goes here. Is it right now? So we'll have equal to 1 multiply 1 divide by 3 multiply 9, which is 1 over 27. So this is the way it works. One way. So another way. Do you have any question about this? So there is another way also. Maybe most of you saw that way. So we had 1 over 9 divide by 3, correct? We had this. So either you are showing in this form or this form, both of them are correct and similar, correct? So now use the same thing I said about 3. 3 is 3 over 1, right?
The reciprocal. I mean, no, I'm just kidding.
Now you have 1 over 9 divided by 3 over 1, correct? So now in Math 120, at one point I remember this was in a book. What you will do, you will keep the first one. Division changes to multiplication. Multiply to the reciprocal of the second number. Now it was 3 over 1, correct? The reciprocal of this one is 1 over 3. Multiplies to 1 over 3. Correct? So now numerators can be together. Denominators can be together because this is multiplication. So 1 multiply 1 divide by 9 multiply 3, which is 1 over 20. So these are both ways that you can step by step go through to find the result or answer of dividing two fractions. Any question? So which way you learned in your high school? None of them?
I did not learn that.
No. Probably cross multiplication
And division.
Cross multiplication, correct? And I can say cross multiplication is the second one, almost, right? So you should know this one. Oh, so now we want to talk about a square root. So I will start from exponent and power that I explained, and then we will go back to see how we can explain a square root or radical using our previous knowledge. Do you have any question about this? Sure? Nope? So, I will start with the easy ones like 2 power 2, 3 power 2. You obviously should know 2 power 2 is 4, 3 power 2 is 9, correct? You should already know this. So I start with 2 power 2, and we know 2 power 2 is 4. Okay? So this is a power, we know this is base, and this is exponent. Let's say I didn't know what was on the left side. I didn't know what is on the left side. So I wanted to reach this point from right to the left, like backward. So radical or square root helps us to go backward to see what was the number, how to, some other number gave us 4. So now obviously you know the answer is 2 power 2, correct? But radical, we show the radical with this, helps us to go backward to find the power, means base, and exponent. Radical 4 says there was a number multiplied to itself. There was a number multiplied to itself gave us 4. So here put 2 dot like this. So that's just explanation. Power 4 says, what's that? Radical 4 says there was a number multiplied to itself gave us 4. So it's kind of going backward. So what was the number multiplied to itself gave you 4?
2.
That was 2, correct? So 2 multiply 2. And this is the value, of radical 4. So now, if I ask you, what is radical 4? You will say answer is
2.
2. Correct? So now, I will give you another example. Radical 9. There was a number multiplied to itself, gave you 9, correct? What was that number? 3. So if I ask you what is radical 9, you will say answer is 3. There is one more situation. We know positive 3 multiplied positive 3 is 9. So what about negative 3 multiply negative 3? That is also 9. Okay? So we will talk about that later, next chapter. We'll talk about radical more, and we'll investigate to see what's going on if we have negative 1 multiply negative 1. 3 multiply negative 3 or such a thing. Now, when I said this, I want to ask you this question. Can I have an answer for negative 9? It means there was a number multiplied to same thing gives us negative 9. Is this possible? This is not possible, because put negative 3 multiply negative 3 gives you 9. Put positive 3 multiply positive 3 gives you 9. So these are all the same possibility. We cannot say negative 3 multiply positive 3 because these are not same. The parentheses are not same. Okay? So for this situation also, that we don't have answer now, we will investigate to see how we can answer this kind of question. So for now, you should remember always, on the radical, you should have a positive number.
So only positive.
Only positive numbers. For now. And then later in other chapters, we will talk about negative on the radical to see how we can answer that question. There is some hint. There are some numbers, we call them imaginary numbers. We will use those imaginary numbers to answer this kind of question, radical negative 9. So now I will add something to radical. Whenever you don't see anything here, so radical should be in this form. There should be a number here, and then there should be a number on the radical. This number can be 2, 3, 4, more than this. Okay? So now, in first chapter, we are just talking about 2. Yes. We are just talking about 2, means a square root. Because the number here is 2. We call that a square root. Because this is opposite of a square, correct? Opposite of power 2. So whenever you don't see any number here, that number was definitely 2. But if they give you a number, the number will be like 3, 4, 5, 6, something else. But if you don't see any number, the index is 2, always. Always. If you don't see any number, the index is 2. And we call that a square root or radical with index 2. So what I call that? Index. Okay? So there are some perfect square. This is perfect square because the number multiply itself and there are whole numbers. So 9 is also a perfect square, 3 multiplied 3. 16 is a perfect square because there was a number multiplied to itself gave you 16. Do you remember what was that number?
4.
4. 4 multiplied 4 gives you 16. Perfect square, okay? And 25. Radical 25 is 5. That's a perfect square too because 5 multiplied 5 is 25.
Could you do 49?
49 is 7. Exactly. The square root of 49 is 7 because 7 multiplied 7 gives you 49.
So you can only do it with numbers that are multiplied by themselves.
There are more situations, more radical. We'll talk about those later. But this is the only thing we will review in chapter 1. Like perfect square, like square root means with index 2. Now these are the only things we will review here. Then later we will have a whole section, dedicated to radical, different situations, like negative under radical, all of these. We will talk about those later. So do you have any questions right now? Sure? Shall we move on? Okay. A square root of 0 is?
1.
0.
0.
Always. So you should always remember this too. We have it in notes. So square root of 0 is 0. The square root of 1 is 1. These two, always remember that. Why square root of 1 is 1? Because 1 multiplied 1 is always 1, correct? So that's the reason. 0 multiplied 0 is always 0, correct? That's the reason. So now we are adding something else to order of operation. So previously we said solve everything in the parenthesis, correct? And then we said from left to the right, multiplication, division first, and then from left to the right, addition and subtraction next, correct? So now we want to add more steps to order of operation. What happens if we have fraction? What happens if we have radical? Because now we learned radical, correct? What happens if we have power? So now the steps will be different. The priority is something else now because we already learned about radical. We already know what is power, okay? So if you have such a situation like this, is that clear now? Okay, so this one. So you have numerator and denominator, okay? It says evaluate numerator first, the top part, calculate top part, everything you have, and then calculate the denominator. So now that we are going to calculate the numerator, what is the priority? Always, always, always parentheses. Always parentheses. This is a rule. Always parenthesis is the first. So we will calculate inside the parenthesis. Innermost parenthesis, like we have two parentheses here, correct? We will start with a parenthesis which is inside this huge parenthesis. Okay? So we should calculate radical 81 plus 3. So now what is the priority here? Radical or power. If you have this form, first start with radical or power. And then as soon as you calculate radical or power, you can add, subtract, multiply, and perform everything else. Okay? So here you will write down radical 81. What numbers number multiplied to itself gives you 81?
6. I mean
9.
Sorry.
9 multiplied 9 is 81, correct? So radical of 81 is always 9. And now you will cross this, you will write down 9, correct? And then the next step is to add these two together, because still we should finish the parenthesis. Correct?
Yes.
So 9 plus 3 is?
11. 12. It's 12.
12?
I'm just kidding. It's 12.
12 is here. Cross this parenthesis and you will write down 12. So now we should solve this. Still we have parentheses there, correct? We are still inside another parenthesis. So we should solve all these parentheses. So this was 12, and then the only thing we have is divide by 1, correct? Nothing more than that. So divide that by 1,
It's
which
still
is
12.
still 12. 12 divided by 1 is still 12. So you solve the second parenthesis.
For a second.
This is the second parenthesis. This was the first parenthesis. This was the second one. Correct?
Oh, so that.
So you will cross this and you will write down 12 above all these parentheses we had here. Correct?
Mhm.
Is that clear? Okay. So now you have 12 here. And then we don't have any parentheses except this one. Correct? We should solve this last parenthesis we had.
That's 1.
2 power 0 is always
1.
1. So instead of this one, you will write down 1.
And then.
Now it will become,
Multiplication.
let me write it down, what it became. So now we have 3 power 2 multiply 2 plus 12, correct? This was 12.
Yes. And
Minus 4 multiplies to
1.
1.
Divided by 2 minus.
Divided 2 minus 2 power 2. So let's finish this numerator now. From left to the right.
Then it goes multiplication afterwards.
No, because we have power, correct?
Oh, we still have another.
Priorities, power, and radical.
Yeah.
Correct?
3.
Before multiplication and division, priorities, radical, and power. So this one,
Is 9.
correct?
So 9.
So in top part, we don't have any radical or power. If we don't have radical and power, the next priority is
Multiplication
and division.
and division.
Correct?
Yeah.
So from left to the right, we will solve all the multiplication and division. Correct? So we have this again. 9 multiply 2 plus 12 minus 4 multiply 1 is 4. Correct? So I will keep that because I said from here to here. From left to the right. Okay. So first I want to solve this one. 9 multiply 2 is 18.
18.
And then I will reach this point. Okay. Because from left to the right. 4 multiply 1 is 4. Okay.
Negative 4. Oh, wait.
Negative 4,
you-
yes.
you know what I mean.
So now from left to the right, if you don't have any multiplication and division, we should start with add and subtract, means addition and subtraction. Okay? So 18 plus 12 is
26. 26. I mean 20, 30. What?
26 is with 4. Minus 4 is 26. Correct?
Yeah.
So now in numerator we have 26. Correct?
Mm-hmm.
So the first two terms gave us 30. Minus 4 gives us 26. So now we finish the numerator. Correct? We should go to the denominator. Is everything fine? Correct?
Yes.
Sure? No mistake yet? Okay. So the denominator, so order of operation. Parenthesis first, correct? We don't have parenthesis. Then exponent and radical, correct? After exponent and radical, we have division and multiplication, and then at the end we have subtract and addition. So now we have power, correct? We should solve that. 2 power 3 is
6. I mean 8.
2 power 3 is 8. 26 divide by, so we don't have power, we don't have multiplication, we don't have what's that? Division.
-4.
We should just combine these two, correct?
Yeah.
Subtract.
I mean, -6.
6.
Not -4.
So positive 26 divided by -6 is always a negative number.
It's gonna be some decimal. Or that works too.
Or we can simplify, correct?
Divided. Wait, I got it. I got you.
Divide by 2,
-4 1/3.
correct? Divide by 2 first. Let's see what happens. Divide by 2, we have 3 here, correct? Divide this by 2, we have 13, right? 13. Am I right?
Yes. Wait.
We don't have, because 13 is prime, we cannot divide 13 by anything else.
Yes. So it will just be -13.
Always simplify at the end. Do you have any question? Too much of information? You should already know most of them. I know, so I see some of faces, they already know everything, and it will be boring for most of the students sometimes. This chapter is sometimes boring. Okay, so what else we have? Section 4. We are again talking about exponent, but you already know how to calculate negative exponent. Okay?
Oh yeah, huh? So we're like.
See, look at this pattern. This is my example. So you just divide every step by 3, correct? And then you will reach 3 power -2 or 3 power -1.
So anything to the power of -1. So 3 to the power of -1 is 1/3. And
now there is a rule for that. Look at this rule. Look at this rule. We have A over B power -n. I can change this power to a positive power.
You can't.
We can.
You can.
Question? We can do that, correct? So how? We reciprocal A over B. The reciprocal of A over B is B over A, correct? As soon as you turn this to B over N, power becomes positive. Then, what else? Let's say you have 1 over A, power -n. Reciprocal of 1 over N is, 1 over A is A over 1, which is A, correct? Do you see that? A over 1, which is A, and then power will change to a positive number.
Yes.
N. And let's say I have A power -n, so it's not difficult. Just follow the rule, correct? Reciprocal of A is 1 over
1
A.
over A.
And then power becomes N. So now for this one, I will give you an example. So we use the reciprocal of parentheses, correct? And then change the power to a positive or negative. Opposite power, opposite sign. Correct? So now I will say what is 3 power -5. You should already say, okay, 3 is inside the parenthesis, correct? And we are using reciprocal of 3, which is 1 over
1 over 3 to
1
the
over
5th power.
3. Power 2?
5.
So which is a positive power, correct?
Yeah, it's just positive.
So now I want to go ahead and see how that power 5 will have effect. So as you see, this fraction, this power belongs to both numerator and denominator because we have whole parentheses around this, correct? Is that correct? So now I want to separate them. I know 5 belongs to each of these numerator and denominator. So I can write down 1 power 5 divided by 3 power 5, right? Does that make sense? Because we had parentheses around all that 1 over 3. So now you should know 1 power 5 is always, just use the definition of power. So what we will do, we multiply 1 to itself how many times? 5 times. So what happens if you're multiplying, let's multiply 1 to itself 1,000 times. So still we have 1. So 1 power 5 is always 1. 1 to any power is always 1. Except 1 power 0. Any number power 0 is always
1. I mean
0.
0. Not 1.
So what happens here? Now you tell me. We know that 1 power 5 is 1, and then we just should calculate this, correct? We will have 1 over 3 power 5, like the way we had 1 over 3, 1 over 9, 1 over 27, correct?
Then we do that thing you showed us earlier.
Which one?
What thing? Hold on. This thing. That thing.
Yeah, so we should use 1 over 3 power 4 divided by 3. 3 power 4 divided by 3.
Well, why it's the power of 5?
Yeah, because we use the previous step, divide the previous step by 3 to reach the next step. When you look at the step-by-step, form, we have big power and then reduce to a negative power step by step. So you use the previous step, divide that by 3. Do you know what she's talking about? She was saying if we had all those patterns, so how we could reach 3 power 5? So obviously we should have 3 power 4, correct? And then divide 3 power 4 by 3 to reach 3 power negative 4, and then we have 3 power negative 5, correct? So just follow the pattern and you will have from big power to the small power. So what else? Do you have any question? And then if you have this form like this, it means A is any number, but X is variable. So you always multiply similar ones. So A and B are kind of similar because they consider as number constant. X are variable. Okay, write this down as a note. Write this down as a note. We have constant. Constants are any number. Any number. 1, 2, 3, 0, negative, positive, whatever. Decimal, whatever. We call them constant. So from now on, whenever I say constant, you should know there was a number there. Correct? Then next definition is variable.
That's the letter behind the number.
Yes. Variables are letters and they are unknown. Variables are letters and they are unknown. Whenever I say variable, means there was a number there, but we don't know what was the number. Correct? So there is a difference between variables and constant. Constant, we already know there is a number and what is the number, but variables are unknown. And in math, we are always trying to solve everything to find the number for that variable because variable is unknown, correct? So we are trying to solve for that variable. Any variable is that. I said any letters, correct? X, Y, Z, W, anything like that can show there was a variable there. So when you see such a form like that, A and B represent constant. Do you see lowercase letter? And then X, Y, Z shows variables. Do you see the difference? So now A and B are similar because they are constant. So multiply them together. Variables have same nature. Put them together. So always you should look at the nature of what you are dealing. So multiply, subtract, add, whatever have the same nature together. And then multiply, subtract, whatever, those variables because they have same nature. So this is the way it works. And also you see n plus m. We already talked about that. When you're multiplying two powers, if the base is the same, keep the base, powers will add together, okay? And then if you have a division like this one, n minus m will be the power because the base is the same. And let's talk about this one. This is the most difficult thing in this chapter probably, but for most of you it should be easy, you know. Scientific notation. You know what? In math, if you look at me, sometimes I'm calculating something. I try my best to not use calculator. In worst case scenario, yes, you need calculator. But in most cases, you can simplify, get rid of lots of numbers, and then you don't need calculator until the end maybe. And you will have a small number to use calculator or whatever to find the answer sometimes. So don't get used to calculator. If you want to, if you have other math classes, try your best to learn to not use calculator that often. Try to simplify, use different methods to simplify everything. Scientific notation help us to get rid of too many digits. So it helps us to get rid of too many digits. We use a form A multiply 10 power n. A is any number from 1 to 9. 1 to 10 actually. 9. Because look, it says less than 10, correct? It doesn't say equal 10. The boundary, look at the boundary. Do you see that? If it was equal 10 means 10 included. Do you understand? If there is an equal sign, this side means 1 is included. A can be 1. But that side, A cannot be 10. So anything before 10. 9, 8, 7, 6, and up to 1. Okay? So the form is this. A multiply 10 power some numbers. N can be anything like, any big numbers. So starting from 1 actually. So let me start with some example like this. 2,000. I want to write this down in a scientific notation.
That's 20,000.
20,000, sorry. 20,000. We have 4 zeros here, correct? 20,000. So we have some zeros. I want to make this like a scientific notation. I will see how many zeros I have here. We have 4 of them, correct? I want to get rid of these many numbers. As much as numbers I can. I can get rid of them using scientific notation, correct? So, you will keep 2, multiply this to 10, and now power of 10 will be the number of digits you have after 2. How many digits you have after 2?
1, 4.
4.
4 after 2.
It will be
It's
2
4.
power, 10 power 4. So the number of digits after 2, okay? Another example will be 5, 1, 2. I want to write this down in a scientific notation. I will write down 5 multiply 10 power. The number of digits after 5 is
2.
2.
Now it's 2.
Okay? So do you understand this? This is not difficult, okay?
Correct.
So when decimal comes to the picture, everything will be difficult. So now I will start with the negative power of 10. And so 10 can't have any negative or positive power, correct? Because I'm going to give you an example now. So we have 2, 0, 0, 0, 0 here, and decimal. So now, as I said, when decimal comes to the picture, it will be difficult, kind of. So I want to write this down in a scientific notation, and I want to keep the 2 here, and 10 power something. So now, first I will say how it works, and then I will say what is the power, and then I will say how it works. So how many power you think I should have?
Negative.
Negative power first of all, because it's that side. Okay.
Negative 5.
Negative
5.
5. 5.
Because you're moving.
Moving from here. Now see what happened. So you will count to see 5 of them are here, correct? But I started from here to count everything to that side. Or you can say start from here to here to count everything. So how it works? Because you could say this is 2, 0. Actually, let me say that. Okay. So you will say the decimal was here, and you are moving decimal to where? To after 2.
Yes. Which is 5 places.
Can you imagine what's happening? 2.0 multiply 10 power negative 5, correct? 2.0 is 2 itself. So what I did, I moved the decimal to exactly here after 2, correct? So that's why I'm counting from this side and say 1, 2, 3, 4, 5. I have 5 digits before decimal that I'm moving. Before the second location of decimal, because that was the first location of decimal, correct? Now the location of decimal is here. That's why I'm calculating between 2 locations, the new and old. So now another example, 0.0005 should be equal to 5 multiply 10 power. We know it's negative because this number is too tiny, correct? Too small. So that's why the power of 10 is negative, because we know negative is a small number, correct? That's the reason.
Negative 4.
Negative 4, correct? Because we are counting decimal, the new decimal, which is after 5, to the previous decimal. So we have 1, 2, 3, 4. Correct? Do you understand this? So for here, we were counting after this. For here, we are counting all the digits here. So, what time is it? So we have 5 minutes. Okay, so I want to give you another example. And let's say we have 0.1234 here. So I just want to explain whatever we have here, then it will be easy for you. So this is a small number, correct?
Yes.
This is a small number, and I want to move the decimal to between 4 and 6, correct? So I want to write down 4.6 multiply 10 power. We know this is a small number, negative. So we move decimal to here, correct? We should count to see how many numbers we have between these 2 decimals. 1, 2, 3, 4, correct? That's why the power is negative 4.
Wait,
right?
did you count from 4 to 0?
Count from here because the new location of decimal is between 4 and 6, correct?
Oh.
That's why. And this one is a good example. 7816. I want to write this down in this form. 7816. Okay. This exactly gives you kind of idea how everything is working. So the new location for decimal is here, and this number is a small, correct? This number is big, correct? So we are trying to make this big number to a smaller number which already has a decimal. Or if we go backward, we should have this small number multiplied to a bigger number, correct? To make it big again, we are going backward. Is that correct? So now, that's why, because we want to make it big again, we multiply to 10 power. 10 power, a bigger number, correct? Positive number. Because this was a big number, this is a small, we should multiply this small number to a bigger number to make it big again, correct? Do you understand this? So the power of 10 should be positive because I said that we need a bigger number. So how many power? We see that. How many decimal change? So this was 7816.0, right? You can imagine it like that, correct? Do you understand this? Like difference between 2, 0, and 2. These are the same. So imagine it was like this. And now the location of decimal is here. So how many numbers we have between these two decimals? 3. The old one. So that's why the power becomes 3. So this is the kind of most difficult exam. But if you understand the concept, you will not have any problem to make everything like scientific notation. So, wait, I didn't say I'm done. 1 minute remains. Be nice, I said camera is recording. Okay. I will cut that point. Okay, algebraic expression. Algebraic expression is something like this. I already explained to you what is constant, what is variable, correct? So in algebraic expression, we have constant, variable, power, exponent, everything, radical, but we have mixture of constant, mixture of with variables. So you can see x, y, z, and some numbers as a coefficient for them. So if we have plus between these, this plus or negative sign between them, separate them to different terms. So we call this one a term. We call this one also a term. We call this one also a term. So what is C? What was my definition of something like C?
Constant.
Exactly.
Constant.
So there is not any variable for that, correct? So that's just a constant. So these are different terms, and then later in other chapters we are trying to understand this algebraic expression to solve for unknown variable, correct? So, okay, we are done, and then go to your assignment and see if there should not be anything complicated. As I said, this chapter is just a review chapter, correct? So we are already done with chapter 1. You are ready to take your assignment finished. So we have homework and quiz. Don't forget, don't come back to me after 1 week. Oh, I didn't know there is a quiz, blah, blah. I'm telling you, there is a quiz and homework for each chapter. We call that preview quiz. Okay, take care. We'll see you next Monday.
I'm scared about this on homework. I'm like not sure about it.
It's not scary. Go do your homework, review everything. If you have any questions, bring your homework to me, or just send me email. You know?
Because it's Sunday. The homework.
Is that?
It's due
previous section. So I will see how everyone is working on that.
I can do everything else. Just this row again.
This one just needs your previous knowledge from previous sections. If you know those sections, you will be good.
Okay.